Okay, let's get started. So welcome back, everybody. Welcome back to the security session for the GSE conference. My name is Jamie Pease. I'm the chairman of the security working group. This is our last session, the security session of the conference, and but that's by all means the conference is not over. There are some sessions that are actually happening scheduled directly after this. And as a quick reminder, the kind of keynote session will be at 5:30 today. That's kind of that's a session with Mark Wilson, who's going to be doing their conference wrap up and close. So I hope you can stick around until then. So before I hand you over to Wai Choi, this is session 5BE for the purpose of feedback. So Wai has put on the QR code on the screen there that you see. So that will take you to the feedback page. So please do give your feedback. And as I said in the previous session, it's we're getting towards the end of the final kind of closing of the conference, and we'll start to look at the feedback that we've got, which contributes to the best speaker and the best user speaker. So it's like if you've got a backlog of feedback to give, it's like quite important that you get that in as soon as you can before we close up. But of course, if you're listening to the recording here, you can still continue to give feedback, which of course will help with the number of CPE, CPD hours that you get from the certificate that you can get from MyGSE. So still a few more people joining. Why? You're very, very popular this afternoon. It's 40 plus now. So Wai has decided to has chosen to record her presentation. So she's going to play that for you just now. So we're going to be keeping an eye on the chat. So do put your questions in the chat, any comments that you've got. Don't be afraid to ask. Like some of you out there, I struggle in the world of certificates, as I've been shamefully admitting to Wai just now. So hopefully, this will be a really good session for you if you are struggling in that area. So Wai, over to you. Thank you very much.
Thank you, Jamie. All right, let's get started. Welcome to this session. I am Wai Choi from IBM RegF PKI Development and Design in Poughkeepsie, New York. Today's topic is what keyring, what certificates. All I know is TLS doesn't work. This session will use a real example to illustrate the concepts involved in digital certificates, from creation, exploitation to debugging in the TLS process. With the basic clarification, I hope it helps you to manage certificates on COS and know exactly what to look for when there is a problem. Certificates is probably the first hurdle in the TLS process. Here is the agenda. First, we will talk about what's the content in a digital certificate through a real example. Then we'll talk about how to set up server and client keyrings for TLS. Then we will talk about some tips on RegDcert keyring setup. And then finally, we will discuss some steps to tackle a certificate-related handshake problem in TLS. Do you know you come across digital certificates every day? You may say you're not sure. But if I change my question to, do you do online shopping? Do you go to your bank's website? Or do you watch some news online? I'm sure the answer is yes. Do you ever take a close look at what a certificate is? Let's go to some websites together. This is BBC's website. From the URL, you can see it indicates HTTPS. Whenever you see HTTPS, you can see a log. Behind the log, there are certificates involved. The log tells us two things. Number one, the certificate is issued by a certificate authority which vouches for BBC's identity. Number two, the certificate is used in the process of encrypting the communication between your browser and the BBC's site. Let's look at BBC's certificate. It contains the subject of this certificate. If you click on the subject name, you can see more details on it, like common name is www.bbc.com, which matches what we put in the URL. It also contains the information like organization, locality, date, and country. And the second thing I want you to focus is on the issuer. If we click on issuer, you can see more details on the issuer, like the common name is GlobalSign RSA OV SSLCA 2018. It also has the organization information and the country information. The BBC certificate and its issuer are part of a certificate chain. With the top one, we call it the root CA. The BBC certificate is the end entity certificate. And between the root CA and the end entity, there are two intermediate CAs. And we call this is an example of a chain of 4. Now, let's take a look at the root certificates. The root certificate also contains the subject name and the issuer's name. But if you take a closer look at the subject and the issuer, they are the same. So this is the characteristic of a root certificate. The subject's name and the issuer's name are the same, and we call it self-signed certificates. You can find BBC's root CA certificate in the browser's trusted certificate store, together with all the well-known CAs. They were installed there when you first install your browser. In fact, if you remove the GlobalSign root CA from the Trust Store, then you will not be able to access the BBC's website. When you visit the BBC website, the BBC server sends a chain of certificates to your browser, and your browser verifies the certificate chain. You can see the contents of the site after the verification is successful. That is an example of a TLS process called server authentication or one-way authentication, since only the server needs to authenticate itself to the client, but it doesn't care who the client is. If the client also needs to authenticate itself to the server, it is called client authentication or mutual authentication. For example, if you need to log in to your bank account with a certificate, that is client authentication. But in this session, we only focuses on server authentication. Let's find out the steps to set up server authentication. Step 1. The server needs to obtain a certificate to identify itself. There are different options. Option 1. You can use utilities from ZOS or other platforms like the regdcert command or the System SSL GSK KYMN utility, or OpenSSL. They are simple to use, but they do not provide any revocation status on the certificate. The RegD certificates do not have full support on certificate extensions. The second option is to buy one from some commercial CAs. They are pretty expensive, although they are the preferred choice if the server is to serve worldwide clients, since the CA root certificate is preloaded in most of the browsers. Another option is to request a certificate from some internal CA, for example, COS PKI services. You need to set up PKI services, but if a large number of certificates are needed, it is worth the effort. It has the full support on extensions like the subject alternate name. Information about the subject alternate name extensions. Remember we talked about the BBC certificate. The common name in the subject is www.bbc.com, which matches the URL. In fact, there is another field that can match the URL, which is called the subject alternate name extensions. You can see that under that subject alternate name extensions, there are several DNS names, like it repeated www.bbc.com there, and also it has 4 more a DNS name. With the multiple names in under subject alternate name extension, you can have a certificate that represents more than one domain. That's why sometimes people would like to have a certificate have multiple domains name. Let's get into more details about how a certificate is generated. First, we need to have a public-private key pair for the server. The key pair is generated in the process of generating the certificate signing request called CSR. The public key is put on the CSR, which also contains identifying information for the server. You may think of a CSR as an application form for a passport. So before you apply for a passport, you need to fill in the application form, which you put in all your information about yourself, and then you sign that application form. CSR is signed by the server's corresponding private key, just like the way you sign your application form. It is your signature. So it is the server's signature, which is created by the server's private key. The public key is put on the CSR, but the private key is not. The server put the private key in a safe place. Then the CSR is sent to the certificate authority, just like we send our passport application form to the passport agency. So in the diagram, you can see that the CSR contains information just like the certificate. It has the subject's name, it has the subject's public key, and it contains the signature. For simplicity, I assume this CA is a self-signed CA, which means it is a root CA. After the CA validates the CSR, it returns a certificate that contains the public key and the identifying information from the CSR, just like your passport containing the information that you fill in your application form. And also it contains other contents that decided by the CA. And also it contains a signature. And this time the signature is created by the private key of the CA. So you can see the certificate information is like what we see from the CSR. It has the subject's name, it has the public key, and also it contains extensions. This basically is a representation of what we introduced in the first few slides that we talk about the BBC certificate. Notice that the private key associated with the certificate, especially the CA certificate, is very important. If you compromise the CA's private key, then all the certificates it has issued will become useless. We just finished talking about step 1, obtaining a certificate. Step 2 is about certificate stores. Both the server and the client need to have certificate stores because certificates must be placed in a keyring or key database or a certificate store before it can be used by an application. From the server side, the server administrator needs to set up the certificate store with the whole chain. In this example, I use a chain of 2. That means the server certificate is issued by the root CA, so it contains a chain of 2. So in other words, the content in that server's keyring is the server certificate and the issuer CA certificate, which is the root CA in this case. And then the server admins needs to send the root CA certificate to the client side, not the server certificate, but the root CA certificate. And this is the place many customer mistakenly thinking that they need to send the server certificate to the client side. So pay attention to this. It is the root CA sending to the client side, not the server certificate. And for the client side, the client administrator also needs to set up its own certificate store or a keyring, which only contains one certificate, which is the root CA certificate sent by the server. So you can see that the root certificate exists in the server key store and also in the client's key store. But the server certificate only needs to put in the server's key store. Notice that in a case of a certificate of N, the server keyring should contain N certificates, but the client keyring only needs the root CA certificate, no matter how long the chain is. That means if it is a chain of 4, like the BBC example, then the server, the BBC keyring, should contain 4 certificates. But your browser only needs to have the root CA there. Let's discuss what's involved in certificate verification. For server authentication, it is the client perform some checks on the server certificate. There are 2 types of verification. The first type, I call them validation checks, which involve checking the certificate's integrity by verifying the signature on the certificate. Is it really issued by the CA it claims? The second check is to check whether the certificate is expired by verifying the expiration dates on the certificate. The third check is to check if the certificate has been revoked. Unlike the expiration date checking or the signature checking, the revoked information cannot be checked right on the certificate itself. Just like your passport, people can check whether a passport is expired or not by looking at the expiration date on the passport. But whether the passport is a stolen passport, it has been revoked or not, you cannot tell from looking at the passport itself. It has to go back to the passport agency to see whether the certificate, whether the passport is still valid. Notice that all the validation checks apply to the whole chain of the certificates. Every certificate involved in this chain must pass all these checks. And after the validation checks, there's another check. I call it trust check. That means to check if the root CA certificate is trusted. Is the root CA certificate of the server certificate installed in the client's keyring before the communication starts? If it is not installed in the client's keyring, even all the validation checks passed, still the communication cannot start because the client does not trust the root CA. It is not in the client's keyring. There are different types of certificate stores on ZOS. We have RegF keyrings. It can be real or virtual. It can be a ICSF PKCS 11 token. It can be system SSL's key database, and it also can be a PKCS 12 package. RegF keyring is the most popular certificate store on ZOS. It can be a real keyring or a virtual keyring. For real keyring, it can be created by regdcert ID ring owner at ring name. It is specified on the application configuration in the format of ring owner / ring name. For example, ftpid / ftpring. A real keyring can be created before or after the certificates have been obtained. For virtual keyring, there's no need to create it. It is just a collection of certificates under the owner's ID. To specify a virtual keyring on the application's configuration file, the format is ring owner /**. Asterisk represents it is a virtual keyring. There is a special keyring called the CA's virtual keyring. It is represented by asterisk AUTH asterisk /**. Keyrings are protected by RECF resource profiles. Application ID needs to have access to the profiles. In the OutDataLab class or the facility class. If you use the OutDataLab class, you create a profile in the format of ringowner.ringname.lst. OutDataLab must be red-listed. This format will provide you granular control on a specific keyring. You can also use the original support, which is the facility class. There are two profiles you need if you use the facility class, which is irr.dissert.listring and irr.dissert.gensert. I would recommend you to use the OutDataLab class since it is a granular control mechanism. I would like to give you some useful regdissert tips. Whenever you specify the regdissert command, you put it into this format: regdissert, owner, function, and other function-specific subkeywords. Owner can be specified by ID, parenthesis, regf ID, for example, ID FTP server. Or it can be predefined owner, set off, site, or multi-ID. There are 26 regdissert functions. Gensert, which is to generate certificate, genreg, generate request, add a certificate, add ring, create a keyring, connect a certificate to a keyring, list chain, list the certificate chain. If owner is not specified in your regdissert command, it defaults to the command issuer. If Mary issues the command regdissert ID John, list chain, label my cert. This displays John's my cert and its issuer's certificates. If the command is regdissert list chain, label my cert, it displays Mary's my cert and its issuer's certs. Don't confuse regdissert add with regdissert import. Add is cert in a dataset to regf. Import is import a cert from ICSF PKSS 11 token to regf. Certificate format is another confusing area. X509 certificates can be packaged differently. It can be a single certificate. It is represented by the extensions like .cer, .clt, or .pem in your PC. It can be a PK7 certificate package represented by the P7B file extension. It contains the N-entity certificate and its issuers. PKS12 package with extension P12 or PFX. It is similar to the PKS7 package, but it also contains the private key associated with the N-entity certificate. The PKCF12 package is protected by a password because it contains a private key. All the above packages can be in either binary or base64 encoded format. Base64 format is a printable format for easy cut and paste. It contains all the printable characters, uppercase A to Z, lowercase a to Z, 0 to 9, a slash, or plus, right? All together 64 characters. The equal sign is for padding. So that's why it called base 64. It represented by 64 characters. So I hope I have built enough foundation about certificate stores. Now, using what you have learned, let's solve a handshake problem from a certificate perspective. Whenever people ask me questions about TLS problem, the first questions I need to find out from them is, are you the server or are you the client? Let's tackle the problem from the server side first. There are 6 areas we need to focus on. Number 1, what is the configuration file which contains the keyring or key database information? Number 2, what is the keyring name and who is the owner? Number 3, does the keyring contain all the necessary certificates? Number 4, which one is the server certificate in the keyring and who owns it? To find out the server certificate in a keyring, we need to find which one is connected as personal usage and which one is marked as default. Marking a server certificate as the default is the most popular setting, and there are other settings you can specify also, but I will use default for the rest of my examples. Number 5, does the server certificate have a private key associated with it and it has status trust? Number 6, what ID will be using the keyring? Does it have access to the private key? Remember, access to the keyring means access to all the certificates in the keyring, but it does not mean the access to the private keys. If the accessing ID is the same as the owner of the certificate and is the same as the owner of the keyring, then the whole setup will be simpler. And also, we have to make sure if the access control is through the our data type class. you have to make sure that class is active and blacklisted. Let's illustrate those 6 steps by using an example on tracing a TLS handshake problem based on a RACF keyring. We look at the server side first. The first thing we look at is the configuration file. We find that the configuration file is profile.tcpip.server. From the TLS keyring palms, I find out the keyring information. The keyring owner is XX server. The keyring name is XX server ring. Then from these 2 pieces of information, I can use the regdesert command, regdesert id XX server list ring XX server ring. This is the output of XX server rings information. As you can see, it contains 3 certificates. Which one is a server certificate? It is the one has usage personal and connect as default. We find out that it has label SSL cert, and the cert owner is XX server. So you can see the cert owner is the same as the ring owner in this example. And so we find out the information is good. From the list ring output, we find out the cert label and the cert owner of the server cert. So we can use the regdesert ID XX server list chain label SSL cert to find out information for steps number 5. So we find out the status is trust. We find the private key and certificate 2 is the intermediate CA. The status is trust. The root CA is also trust. So we have a complete chain. It contains this ring contains all the certificates we need. Finally, we check the access. We check whether the application ID has access to this keyring. We can do a outlist, outDataLive XX server, the XX server ring, the LST. If XX server is the application ID, it only needs read access since it is accessing its own keyring. But if the application ID is YY server, it needs update because it needs to access XX server's private key. Make sure that if you use the outDataLive class, it has to be active and blacklisted. We can do set list and see whether outDataLive is under the active classes list. And also we look at the rec list and see if outDataLive is there. And remember, we have to do a rec list refresh. Let's move to the client side. The steps involved are similar to the server side. Number 1, what is the configuration file, which include the keyring database information. Number 2, what is the keyring name, who is the keyring owner. Number 3 are the certificates, of certificates. Number 4, which one is the root CA certificate of the server? Is its status trust? Number 5, what ID will be using the keyring? Does it have access to the keyring? Access to the keyring means access to the certificates in the keyring. If the access control is through our data lab, make sure it is active and blacklisted. Let's look at the client side now. We use a real keyring first. Again, we first find out the configuration file. This is profile.tcp/ip.client. We find out the ring owner is XX client. The ring name is XX client ring. Then we use the registered ID XX client list ring XX ring to find out the certificates inside this keyring. And we find the set of owner, and we find out the CA certificate label is XX server root CA. After knowing the label, we can do register set of list label XX server root CA. We have to make sure this is the server's root CA sent by the server side by checking the serial number, the issuer's name, the subject's name, and we check the status is trust. Again, we need to check the access. We can use the our data lab class also. So we do a our list, our data lab xx client.xx ring.lst. Assume the client application ID is xx client and it has read access. If the client application is YY client, the access is also read because YY client access XX client keyring, it doesn't involve any private key, so just read is sufficient, unlike the server case. Because in the server case, access is needed for the private key, but from the client side, no private key is involved. Again, make sure our data lab class is active and blacklisted. Right? So you check using the setup list to find out the information and make sure you refresh the class. In a server authentication scenario, the clients can also use a virtual keyring. So from this configuration file, you'll find out the keyring, and the keyring can be specified by asterisk of asterisk slash asterisk. Then you can use the registered set of list to list out all the certificates under set of. And you have to go through all the certificates and then find out the one that is the root certificate sent by the server by checking the serial number, the issuer's name, the subject's name. You can check the access by our list our data lib certif auth dot irr underscore virtual underscore keyring dot lst. This is a predefined string for CA's virtual keyring. You check whether the XX client has read access, or you can use the old facility class. Our list facility irr.listring. You check whether the XX client has read access. Let's refresh some key points. Keyring setup is the first area to debug in TLS problem. There are three IDs you need to find out for the server side. First is the keyring owner. You can find the keyring owner from the system SSL log. Try to find out the GSK underscore open underscore keyring. If you include the ring owner in the configuration file, you can see it will display as ring owner / ring name in the GSK open keyring entry. If you don't specify the ring owner in the configuration file, then you can try to find out the job name from GSK underscore DLL underscore init underscore ones, and from the job submitter based on the job name, you figure out what the key ring owner is. The second ID you need to find out is the certificate owner. This can be found out by the regdcert list ring and list command. The third ID you need is the access ID that access the keyring and the private key. That means that is the ID which reads the configuration setup. You can find this access ID from the TLS log in the message EZD1286I indicate the user ID. These three IDs, they don't need to be the same, but it will be simpler if all of them are the same ID. That means the accessing ID is accessing its own keyring and its own certificate. Before adding certificates to regf, use regdcert checkcert on a dataset containing the certificates to check if they already exist in regf. Use regdcert list chain to list the certificate chain. But if there are more than one chain, it may not display the one you expected. It uses the one exist earlier to form the chain. This happens when you have two CA certs have the same public key. Then there may be two paths chaining to the same root CA, depending on which CA is added earlier. You want to keep the minimum number of certificates in a keyring because unnecessary certificates affect the handshake performance and may even cause outage. regf provides the regf underbar certificate underbar expiration health check showing expiring and expired certificates. So don't wait till the last minute. Remove the expired certificates from the keyring and delete it from the RegF database if it is only used for the TLS process. Or if you don't feel comfortable of deleting it, you may do a regdcert alter the status to no trust, because no trust certificate will not be used in the TLS process. It is the responsibility of the server side to send the root certificates in a file to the client side before the communication occurs. Once you are sure the keyring setup is correct, then you can proceed to debug the other areas like the cipher suite in the TLS process. Let's find out how much do you remember all about the certificates, the certificate keyrings. If you can get all these questions right, that means you remember most of the material. Number one, are there more certificates in the server keyring or the client keyring? Right, it is the server keyring contains more certificates because it contains the whole chain. The client side only need to have this root CA. Number two, what information is the starting point to tackle a TLS problem? A, certificate content, configuration with keyring specification, keyring content, authority of the ID that accessing the keyring. Which one you need to find out first? Yes, it is the configuration first, because the configuration is the starting point that gives you the keyring information. Number three, what is the logical order for the above information? Which one, right? We already answered the question. The configuration is the first one to find out. So you can eliminate A and D. So what's the answer? B or C? Right. It is B. After the configuration, you find out the keyring content, and from the keyring content, you can find the certificate content, and then lastly, you try to figure out the authority of the ID that need to access the keyring. I hope you get all correct. These are some references for you. And we have some PKI rep books. The one that say quick setup is for you to set up PKI services quickly. All right, now it is your turn. Hopefully you get the practical steps how to chase a problem. So do we have any questions?
Hi, Roy. We thank you so much for that. We have got a question from Damien Dunn. Hi, Damien. So he says, can you please confirm my understanding from this presentation? On a server side, we have a cert chain, e.g. root certificate, issuing certificate, and service certificate. In this scenario, have I understood that only the root certificate needs to be provided to the client for storing in its true store. In this case, the client does not need the issuing nor the server cert. Have I understood this correctly, or does the client need the root and issuing certs?
So it is the server side have all the whole chain. The client side only need to have the root. Yes, I know that some people will put the intermediate to the client side also, but I would recommend to put all the burden on the server side, because when you set up your keyring, you know what is the chain, you know it. You don't want to let the client to know all these. They don't need to know all these details. They only need to trust the root CA. That's all. When you have the whole chain from the server side, you send the whole chain to the client side, and the client side just need to check whether the root CA is in its keyring. That setup is much simpler. It's easier to debug. The more certificates in the keyring, the more confusion, and it will sometimes, if the server side get a new certificate from some intermediate CA, but your client side still keeping the old intermediate CA, then it will the communication will not work. The handshake will fail. So it is easier to have the server side has the right chain and just give the root CA to the client side. Yes.
Does that answer your question, Damien? He says, thank you for that clarification. We have a habit of sending the full root intermediate chain to the client, one for us to review. Tim Perkins says, ask the question, can list chain be used with a certificate in a DSN, or does it only work with certificates that are already loaded into RACF?
List chain lists all the certificates installed in RACF. The chain, if it's already installed in RACF, list chain will display it. Check cert is checking the certificates in a data set. But if the certificate in the data set already in RACF, it will show you that. You can tell from the output from checkcert if it contains a certificate label, that you know that it has been installed in RACF, because label is not something inside the certificate, right? It's something that RACF put in as like metadata for the certificate. So list chain and checkcert kind of displaying similar information, but one is displaying the certificate in a data set. One is displaying certificates in RACF, already installed in RACF.
And he says, was hoping to be able to check if the required CAs were in RACF for a new client certificate.
Say that again.
He says, Tim says, was hoping to be able to check if the required CAs were in RACF for a new client certificate.
The needed one. So you have a an entity cert, right? And after you get the N entity cert, you do a list chain on that. So before you install, so you do a check cert. You check cert on that N entity cert that's in the data set. And then you can see whether the chain is in RACF. If it's in RACF, as I said before, you can see the check cert command will show you the output of its issuers. If you don't see it in the check cert output, that means the CA is not there yet.
Okay. And Tim says, okay, thanks. So Damien, your line's unmuted. You have another question? Don't think we can hear you. I'll read out your question. So Damien says, may I take the liberty whilst we're here, please? Of course. In a current SSL handshake, we see in the SSL trace a send certificate from the server to the client. However, we receive back a decrypt error event 51. Any suggestions as to what might be causing the issue? Just thought I would ask if you have seen this scenario. If not, then we'll need to investigate further and open a PMR if needed.
So the question is, what the server? What is the problem again?
Can you are you able to unmute Damien? Not sure he is. So do you want me to read out the question again? He says he can't unmute. So he says, in a current SSL handshake, we see in the SSL trace a send certificate from the server to the client.
Mm-hmm.
However, we receive back a decrypt error event 51. Any suggestions as to what might be causing this issue?
It is the decrypt error. It's not keyring or certificate problem then, right?
Yeah, he says a decrypt error.
Right. So, so
yeah,
I think
yeah, he said he confirms it's a decrypt error.
Okay. So it is not related to the certificate keyring then. And this session I only cover the certificate aspect. So the way is to get a trace from SSL the trace log, and then try to find out from there.
Yeah, and open a ticket with IBM by the sounds of it. Yeah.
Yeah. I am trying to help you to jump over the first hurdle, because most of the time it is the certificate problem.
Yeah.
Right. And then it doesn't mean that after you solve the certificate problem that it solves all the problem.
Yeah. Yeah.
Right.
And he says, okay, perhaps we're looking in the wrong place. Thank you. Thanks, Damien.
But first, make sure it is your certificate and keyring set up correctly first.
Yeah.
Otherwise, you will like chasing a problem that is not the cause. So make sure, so that people will question you, because the first thing people will say, are you sure your certificate and keyring is correct? So you have to give them the evidence saying yes.
Yeah.
Right? Because you now know what are the steps, what to look for. You can show all the evidence saying that my certificate setup is correct.
Okay. And I have a question for you, if I may. So I'm curious to know, so traditionally people have always kind of put their certificates in the RACF database, you know, from years gone by. Is it more so now that people put it into ICSF, or is it still kind of a mixture, or so would you say?
It's a mixture.
Okay.
Yeah.
It's just interested
So
to know sort of the trend of, yeah.
It just like SSL certificates is not a long-term use, right?
Mm-hmm.
Like several months, or it just a year or two. So people may say, I'm okay that just put it in the with the key in RegF. I'm fine with it. But for like the CA certificates that can last for 12 20 years, 30 years, that people may want to put it in a in ICSF. But for
Yeah.
your end entity, that many people think using the RegF to store it is fine.
Okay. And Damien says, great question, Jamie. We're considering what's best also. So you heard it here first, Damien. So we have a question from Mike Balsam. Hi, Mike. So he says, is there a way to add multiple SANs to the certificate request? We do not seem to be able to get this to work with RACD cert gen cert.
Sorry, no, you cannot use RegD cert. But if you find a way like system SSL, they can let you to generate requests with the multiple SAN, and then RegF can sign a certificate with those multiple SAN. But when you display it in RegF, it still won't show you. That is something that people always ask to enhance RegD cert. But our thinking is, since we have the full support from PKI services and we don't have enough resource to do both part, and RegF is not a real CA, and we want people to use the real CA function. That's the PKI services.
Yeah. Okay, thank you very much. And it doesn't look like there's any more questions. Some great questions, by the way, folks. Thanks for those. So, thank you very, very much for taking us through your presentation. And I know you're frequently on RACFL, and I know one of the reasons you wrote this presentation was because, there's sort of the frequently asked, the problems that are coming through. And I think from memory, you're maybe looking to give us a more of a advanced session, perhaps at GSE next year. This is kind of to sort of warm people up and help sort of troubleshoot those issues. So I'm sure you'll be back with us next year for a kind of a version 2, take us sort of to more of the advanced levels. Well, at least I hope so. Anyway.
Yeah, sure. Yeah, sure. So that's what the we have the feedback, right? So if you can do a feedback and also tell us what you want to do, what you want to listen to, that will be very helpful for the planning for the next sessions.
Indeed. Yep, so that's session 5BE, folks. So you can use the QR code there or go to the agenda and click on Y session and scroll right to the bottom, and you'll be able to see the feedback button there. And it's like really important now that you get your feedback in as soon as possible.
This session, I am
Oh, you're replaying it. Because we're the conference will close in 2 hours from now, so we're collecting the feedback so that we can work out who the best user speaker is, and of course who the best vendor speaker is. So it's important that you do that. If you're also listening to the recordings in the future, and by the way, those recordings will be available in the coming days. They'll be available on the website, and you'll be able to listen to those at your leisure. You can still give feedback through the website, so that you can get your CPD or CPE certificate. You can claim your points there. And yeah, a lot of the presentations now for the security stream are available on the website. So if you just look for the little man, the little blue man, and click on him, providing you're logged into my GSE, you'll be able to download those. And Y's been very good. She's put hers up as well on the website, which is great. So The next GSE security meeting, as I said in previous sessions, is going to be on February the 4th, 2021, and that's going to be virtual over Zoom. And we are also looking for presenters for that meeting. It's going to be a full day event, so it will start at 9 and finish at 5. So you've got something like 7 sessions to get through. So we're looking for presenters. So do come forward. My email address is jamie.pease@gsc.org.uk. So just send me a presentation title and your proposed abstract. You'd be most welcome. This is the final security session of the conference. I can't believe it. After 2 weeks, we've had 17 hours of, I think, fantastic content. So a big thank you to all my presenters. You've done us proud. I think that the platform that we've been using as Zoom has held up really well. A big thank you to Gino, who's been our technical support guy behind the scenes, and also to my co-pilot, as I've been calling her, Sue Parsons. Thank you, Mrs. Parsons, for being by my side over the last 2 weeks. But I think it's been great. But the conference isn't over. Now I sound like I'm doing a closing speech. I'm just closing the security track, but the conference isn't over. So we've got a break now. There's 20 minutes until the next session at 4:30 UK time, and there are there's 4 sessions from 4:30 till 5:30. So do join those if you can. And then at 5:30 GMT, we've got a conference wrap up and close with Mark Wilson, where I believe the best speaker and best user speaker will be announced maybe. So please do join us for that. And finally, don't forget our charity for this year. If you can donate, please do. The charity, the link to the charity is all over the agenda. If you just look for Virgin Money Giving, click on that link, and then it will take you there. So I know that the donations have been going up, and so thank you for your support there. But I think that's it, isn't it, Sue? Are we done?
I believe so.
Thanks for. Sorry,
yeah,
why?
Yeah,
on.
I have a exercise left for the participants if they're interested.
Oh, okay, go for it.
Yeah, right. So you just I want to make sure that you have this idea get into your mind about the keyring setup. So the thing is, you draw 2 circles. One circle is the server ring. One circle is the client ring. And we mark up, there are 2 chains. So you know what a certificate chain is now, right? It is from the end entity to the root CA. That's the whole chain. So write down 2 chains. Chain 1, I called it A, B, C. And A is the root. C is the end entity. All right. And then you have another chain. Chain 2 is X, Y, Z. X is the root. Z is the end entity. Okay. Now, I ask you the question to put in the right certificates in the server keyring and put the certificate needed in the client keyring for the server authentication scenario, which is what I talked in this session. I only talk about server authentication. All right, A, B, C, X, Y, Z, and put it in the 2 keyrings. Got it? And then try to say, I haven't talked about it, but use the same principle you learn about server authentication. So if I want to have client authentication, which means mutual authentication, so what additional certificates are needed in both rings? If you get it right, you graduated. Yay.
All I can say is, why, I think I need to go to special measures class.
But you should get the server authentication right. So there's something Lee for the participants to try it out as a as a revision on what they have learned.
Yeah,
So,
there you go, folks. That's your homework for tonight.
right, 2 rings,
Yep.
2 rings and 2 chains.
Yeah.
Yeah. So you may we may talk about it. You can send me emails that you want further discussion, or we can continue in the forum, the RegFL.
And please don't ask me to send in my homework tonight.
Okay, I give you a week.
Oh, thank you. That's very kind of you. Thank you so much once
All
again,
right.
Moi, and we'll have you back, and we look forward to seeing you next year. And thank you, everybody. Stay safe, everybody, and we will see you soon. Take care. Goodbye.
Bye.